Hello everyone. I hope you all are doing well and let us start one more question from statistical mechanics. Consider a system n non-interacting particles in which the energy of each particle can assume two and only two distinct values. See what is saying that consider a system of n non-interacting particles. That means non-interacting means classical particles. Their interaction is zero. That means the potential energy is zero. Okay. In which the energy of each particle can suppose that distinct energies are 0 and E. Denote N0 and N1 the occupation numbers of the energy levels 0 and E. Suppose energy level 0 and E and its occupation number, that means number of particles in 0 level is N0 and N1 be the number of particles in the energy level E, and the total particles is N0 plus N1 equal to capital N. Okay, and the fixed total energy of the system is U. Then we have to find out the entropy of the system. Okay, let us start the solution. Here we have to find the entropy. As you know, the formula of entropy is Kp ln omega, and here omega is the number of microstat, and we can find by the formula of n factorial divided by n1 factorial n2 factorial. Here n1 is equal to n0, n2 equal to n1. So n factorial by n0 factorial, n1 factorial. So s will be Kv ln n factorial by n0 factorial n1 factorial. Okay, then the question number B is find the temperature as a function of U for what range of values of n0 t is less than 0. Okay, see the things is here n0 plus n1 is equal to n. B, let me draw again. This is 0 and E, and number of particles N0, N1, and total number of particles is N0 plus N1 is equal to capital N, and the another thing is N1 U1 plus N2 E2 is the total energy U. So here N1 is N0 and E1 is 0 plus N2 is equal to N1 into E2 is E is equal to U, and that implies N1E is equal to U. Okay, so N1 is equal to U by E, and then N0 will be capital N minus N1, that will be N minus N1 is U by E. Keep in mind, then the question, according to the question, find the find the temperature of the system as a function of U. As you know, if the number of particles in the upper state is N1 and number of particles in the lower state is N0, by the Maxwell-Boltzmann relation for classical particles, N1 will be N0 e to the minus beta E. Okay, here beta is equal to 1 by kT, and then N1 by N0 will be, if you do simplification, it will be minus E by kT, and take the ln of both the side, then ln N1 by N0 is equal to minus E by kT, and if you change the N1 to N0, then that will be E by kT is equal to ln N0 by N1, that implies T will be E by K ln N0 by N1. Okay, this is the expression of T. Then we have to find out the T in the torque U. So T is equal to E by K ln place N0 as N minus N1 divided by N1, and you know we obtain n1 equal to u by e, then put the values e divided by k ln capital N minus n1 is equal to u by e divided by u by e. If you do further simplification, then e by k ln ne minus u divided by u. So this is the answer in terms of u, temperature in terms of u. Okay. And then what is the question? Question is here B question is not finished yet. See what's asking. For what range of values n naught t less 0? You have to find the range of n naught for t less 0. So our t expression is equal to e by k ln see this one n naught by n1. T less 0, that means this 0 less e by k ln n naught by n1, and t less 0, you can put that that t is 0. If you do equal by equal sign, then things will be ln n naught by n1 is less than 1. That implies n naught by n1 is equal to ln n naught by n1 will be less than 0. If t less 0, then n naught by n1 will be less 1. If you do exponential on both the sides, then things will be see, we have to find out n naught. So replace n1 by n naught, then n naught by n1 will be n minus n naught less than 1. That implies n naught less than n minus n naught. That implies 2n naught less than n. That implies n naught will be less than n by 2. Okay, this is the thing when temperature less 0. And then question C is, in which direction does heat flow when a system of negative temperature is brought in contact with the system of positive temperature? What do you mean by negative temperature? See the thing. Negative temperature means if this is level 0 of energy and E, if the population in the lower level is less as compared to the upper level, the population inversion occurs. That means at T less 0, the number of particles in the upper states is more as compared to the lower states. Okay, this is the negative temperature. And positive temperature is just the opposite. If the number of particles in the lower state is more as compared to the upper state, this only occurs when T greater 0. So that is the positive temperature system. This is negative temperature system. As a question is, both the system are keep in contact. Suppose that system minus T negative temperature, this is plus T, keep in contact, then the energy will flow from in heat energy flow in which direction? See, negative temperature means the number of see, the energy is more because this is 4e and this is 2e total energy. So 4e and 2e. So energy always flow from higher potential to lower potential. So heat will flow from negative temperature to positive temperature system. Okay, this is the thing. We already solved the 3 things, and keep watching. Thank you.